This tutorial is about running chi-square goodness fit test in SPSS. The example we're going to use is from this slide. In a study in a California county, researchers compared the demographic characteristics of members of grand juries to determine how closely these juries reflected the population of the county. If the juries were selected randomly or impartially, then the characteristics of the jurors should closely match those of the larger county. However, if attorneys were tilting the jury selection process, then the jurors' characteristics would be quite different from the county. So here we have our data, and here there's age in the categories. And this is a countrywide percentage for each age category. And this is the number of jurors in each category. So we're going to use this data set to find out if the demographic characteristics of the jurors represent the country demographics. So we're going to enter the data in SPSS. So go to variable view. I'm going to create a variable called age. And go back to data view. We're going to have age going to have 4 categories. I'm going to code each of the category with 1, 2, 3, 4. And go back to variable view. And I'm going to reduce the decimals to 0. In the values here, I'm going to label the values. My ones are those in the age range of 21 to 40. The twos are from 41 to 50. And the threes are from 51 to 60. And the 4 is for people who are over 60. So these are our labels. And we're going to create another variable. It's called frequency. And in that, we're going to tell how many people in each age category. So if I click on value labels, so that's we know our labels for each of the codes. In the age range of 21 to 40, the number of jurors are 5. For this age range, the number of jurors are 9. For 51 to 60, the number of jurors is 19. And for those who are older than 60, the number of jurors are 3. Back, I'm going to reduce the decimals. And so that is our data. Yeah. So if you look at this, the number of people we have in our data should be the sum of the number of people in each of the age category. So that will be we're going to sum up all these values. That's the total people in our data set. So for the chi-square, we'll need to weight the data. So go to data, weight cases. We're going to weight cases by frequency. Okay, so the program knows for each of the age range how many people we have. And now we're ready to run chi-square goodness fit test. We're going to compare the frequency in the number of jurors compared to the frequency in number of people each of the age category in the county. Yeah. So go to analyze. So to run goodness fit test, we go to non-parametric tests, Lexi dialogues. I might not be able to see here. Yeah. So the first one, that's a chi-square. Yeah. And we're going to, because we're interested in the age, so we're going to put age here. And then, we're going to tell the program what are the expected values for each of the age range. And we're going to add the expected values according to the order when we coded the age, from 1 to 4. Yeah. So the number 1 is the age range from 21 to 40. Yeah. So the expected values are the county percentage, which from the slide we have is this is 42%. So it's 0.42. The second age category, 41 to 50, the expected one is 23%. And the third category, from 51 to 60, the county percentage is 16%. And the last age category, that's for people older than 60, the county percentage is over 19. And check options. So we're going to have descriptives and continue, and then OK. The descriptives here are not that informative. Mostly we're just interested in number of observations. Here we have 36, which is you add up all the number of observations for each age category. So here these are observed frequency for each age range, and these are expected frequency. So these are so based on what we entered, the count is a percentage. So the first age range count is percentage is 42%. So 42% times 36, we get 15.1. And so it's the expected frequency is 15 people in this age range, and we have 5 here. And the expected range for this one is 8, and we have 9, so it's about similar. And then for expected frequency for 51 to 60 years old people is about close to 6. So that is expected frequency. The residuals is the difference between the observed frequency and expected frequency. So you can see that there's a large discrepancy between observed frequency and expected frequency in the youngest age range, and also in this age range, 51 to 60. With the youngest age range, that was underrepresented in the jurors, and this age range is overrepresented in the juries. So the chi-square calculated is quite large, because the residuals are large. And so 39.425. The degree freedom is number categories minus 1, so which is 3. And you can see that the sig value is less than 1 out of 1,000. So if there's the demographics for the jury is no different from the county's demographics, then there's a less than 1 out of 1,000 chance to find the discrepancy is large. So we reject our null. And so that is the chi-square goodness of fit test.